So next you can see the problem. A low loss line with R0 is equal to 70 ohm is terminated at an impedance of ZR 115 minus J80 ohm. The wavelength of transmission line is 2.5 meter. Using Smith chart, find the following. So what are the parameters they are asked to find? Load admittance, standing wave ratio, maximum and minimum line impedance, distance between the load and first voltage minimum. Okay, so you want to find these parameters. Okay, so in order to find in all the problems, first of all we will find, so Smith chart la normalized form la da நம்ம என்ன பண்ண முடியும், solve பண்ண முடியும். So you want to find normalized load impedance. So here given, they have given the ZR value, that is 115 minus J80, and they have given the R0 value was 70. So how will you find the normalized load impedance? ZR by R0. Okay, so the value is 1.64 minus J 1.14 value. Okay, so first of all you want to plot this normalized load impedance value. How will you plot this? 1.64. Okay, so we know it is the real axis. Okay, so where is 1.64? So see here 1.64. So you want to mark in the constant resistance circle. Okay, so constant resistance circle. So 1.6 is 1.2, 1.4, and here it is 1.6. Okay, 1.6. And next, what is the value? Minus. Okay, so it is very, very important. So negative sign. So minus J 1.14. So negative means it is the other part, that is the below part. Negative வந்து capacitive component. So என்ன பண்ணுவோம் நம்ம, the above componentல positive எடுப்போம், below component negative எடுப்போம். அப்படிதான். இப்போ minus 1.14. So it is 1.6. Okay, so this arc, so where the 1.14. Okay, so 1.14 in the arc value. அப்படிதான். So 1.14 எங்க இருக்கு? So see here, it is 1.2 and it is 1.4. So in which point this 1.4, so it is J 1.14, not 1.4, 1.14. So 1.14 means it is 1, it is 1.2. In between this 1 and 1.2 there is 1.14. It is 1.0 means it is 1.1. Correct? Okay, so here there will be 1.14. So this point. Okay, so here 1.14 and it is cutting at 1.6. So the intersect of this point and here this 1.14 point. Okay, so it is the point that is the normalized load impedance. Okay, 1.64 minus J 1.14. So it is the point. So with mark this point as a with OA as radius, taking a compass and you want to draw a circle. Okay, you want to draw a circle with OA as radius, draw a circle. It is the first step. Okay, this is the first step. And so what they had was to find the load admittance. Okay, so now we had find the normalized load impedance and we had marked in the Smith chart. Next you want to find the admittance. You know, admittance is the inverse of impedance. Correct? Okay, so how will you mark in the Smith chart? Means, so it is admittance. So extend this impedance. So extend this impedance circle. Okay, extend this impedance circle and mark it as B. So the point which is intersect, the point at B is the admittance value. Okay, normalized admittance. So what is the value? 0.41. That is the admittance value, y into R0 value. Okay, so this value is y into R0 value, that is 0.41. Extend this line, so you got 0.41 plus J 0.31. So now in order to get the load admit, so it is normalized value. அப்படிதான் நம்ம ஸ்மித் சார்ட்டில் கிடைக்கிறது வந்து normalized value. You need the load admittance value, so you divide by R0. So what is R0 value? 70. So you got the load admittance value. So you get the first parameter, admittance. Can you understand? So how will you find impedance? So impedance, the intersection of constant resistance and constant reactance. Second, if it is negative means you want to mark in the below, positive means above. Next, you had find the admittance. So in the Smith chart we will get only the normalized value. So in order to get the normal load admittance, you want to divide by the characteristic resistance 70. Can you understand? Next, they had asked to find the standing wave ratio. How will you find standing wave ratio? So in previous problem itself, we see the right hand side, the intersecting point in the circle, that is 2.6. So it is the VSWR value. Okay, so it is the VSWR value. So that is 2.6. So this is the VSWR value. Okay, and we had find the standing wave ratio. Next is the maximum and minimum line impedance. Okay, maximum and minimum line impedance. So how can you find the maximum and minimum line impedance? So you know the maximum normalized impedance is this point, that is the VSWR value is the maximum normalized impedance, and this left hand side is the minimum normalized impedance value. So it is the maximum normalized impedance. So what is that value? 2.6 plus J0 is the maximum normalized impedance. Okay, so maximum line impedance எப்படி find பண்ணுவோம்? Into R0 value. So in second unit we study one formula, that is maximum impedance value is Z0 R0 into S, correct? Is it not into S or not into S? So here the value is 2.6. You R0 value is 70. You got R0 as 70, you know, and into S value is the VSWR value. Yes, okay. So same formula only for maximum line impedance. We are multiplying with R0 into the maximum normalized impedance, that is 2.6. You got 182. Okay, so you got the maximum line impedance. Next, you want to find minimum line impedance. In order to get the minimum line impedance, you want to see the left hand side value. So here what is left hand side value? It is 0.2, 0.3, and then before the line of 0.4. So what is that? 0.38. Okay, so the minimum normalized impedance value is 0.38 plus J0. So what is the minimum line impedance? You want to multiply with R0. Okay, so into 70. So what is the answer? 26.6 ohm. So you got maximum and minimum line impedance. Can you understand? Next, you want to find the distance between the load and the first voltage minimum. How will you find the distance between the load? So I said you here there are three. First is the wavelength. So that is the clockwise direction, wavelength towards generator. So inge irundhu start out. Next, wavelength towards the load. So it is the load line. Okay, so it is the load line and it is the minimum line. So you want to measure what they had asked, distance below from first voltage minimum. Okay, so it is the voltage minimum. Okay, so this is the voltage minimum. So extend this line. So இந்த லைன் எக்ஸ்டெண்ட் பண்ணிக்கோங்க. ஸோ டுவர்ட்ஸ் த லோட்னா எங்கே இருக்கிறது பார்க்கணும், இந்த இன்னர் சைடு. இது வெளியில் இருக்கிறது வேவ்லென்த் டுவர்ட்ஸ் ஜென்ரேட்டர், தட் இஸ் த கிளாக் வைஸ். நெக்ஸ்ட் இஸ் த ஆன்டி கிளாக் வைஸ் டைரக்ஷன் டுவர்ட்ஸ் த லோட். ஸோ எக்ஸ்டெண்ட் திஸ் லைன். ஓகே, so we want to measure the distance from the minimum to the load value. So it is intersecting at the point. So inner value பார்க்கணும். Okay, outerல இருக்கிறதுல உள்ள இருக்கிற வேல்யூ. ஸோ வாட் இஸ் தட் வேல்யூ? 0.198 லாம்டா. 0.2க்கு பக்கத்தில் இருக்குது. 0.198 லாம்டா. இந்த கொஸ்டின் they had given the value of lambda as 2.5 meter. Okay, so in order to find the first voltage, what is 0.98 lambda? We get the value as 0.198 lambda. So 0.198 into 2.5 into 2.5. Okay, so you got the answer as 0.495 meter. Can you understand? Okay, so see in similarly another one problem here, 50 plus J50. Plus means you want to mark it at the above point. Okay, so மேலே மார்க் பண்ணி, ஸோ சேம் திங் தான் ஃபைண்ட் பண்ண கேட்டிருக்காங்க. ஸோ இங்கே வேல்யூஸ் எங்கே மார்க் பண்ணணும்னா இந்த above side of the constant, that is the reactance circle, இங்கே மார்க் பண்ணணும். அண்ட் another one thing, இங்கே நமக்கு லாம்டா வேல்யூ கொடுத்துருக்காங்க, இங்கே ஃப்ரீக்வன்சி வேல்யூ கொடுத்துருக்காங்க. ஸோ வாட் இஸ் லாம்டா? லாம்டா ஃபார்முலா இஸ் C by F. You know C is equal to 3 into 10 power 8 and frequency here given as 300 megahertz. Okay, so இதை வச்சு ஃபைண்ட் பண்ணணும். Can you understand? Both are same method problem. Here positive sign, okay, positive, and here they had given the frequency value. இங்கே lambda value கொடுத்தனா இங்கே frequency value கொடுத்துருக்காங்க. Okay.